Welcome to Insight Hub, the video series dedicated to the world of data and brought to you by Miracles Data Practice.
Hi, and welcome to Insight Hub video series. I am Divya Mutta from Miracles Innovation Lab, working as Machine Learning Research Associate. Today we will be talking about how to detect license plate and identify registration details using OpenCV and Python. Here is our agenda for today. We will see what is license plate recognition and how it is helpful, what algorithm we are going to use to achieve it, real-time applications, and live demo, followed by steps and architectural flow. What is license plate recognition and how it is helpful? License plate recognition, shortened as LPR, is a feature on some software that can detect, read, and store image of a car's license plate. It is used primarily in traffic monitoring, in parking lots and security entrances of gates, and to track a known suspect's vehicle and to find a vehicle or a car involved in a crime. And the algorithm we are going to follow is, the algorithm we used here is KNN. It is K-nearest neighbor algorithm. It is a simple algorithm that stores all available cases and classifies new cases based on a similarity measure. KNN belongs to supervised learning and finds application in pattern recognition, data mining, etc. KNN is used for both classifier and regression. In KNN classification, the output is assumed as a class membership. An object is aggregated by majority vote of its neighbors. In KNN regression, the output is property value for the object. This value is average of values of its k nearest neighbors. Here at beginning, the KNN needs to be trained using an image with different font types of alphabets and numbers. When an image is uploaded by the user, in the backend KNN extracts the license plate number, and that extracted license number is checked with database to find registered user details. And now coming to the real-time applications. Situations that call for license plate capture may be very specific. This feature is very important if you need to secure an area such as military base or research facility, monitor gated entrances and parking lot traffic, track a known suspect's vehicle, find a stolen vehicle or car involved in the crime, enforce parking laws including time limits or reserved spaces. And now let us go with the live demo. Here it is our web page which we have created for LPR, that is license plate recognition. The image was uploaded by the user. For example, I have taken 10 images which were stored in the database. These are the examples which were stored in the database. The database I used here is SQLite. The image is selected from one of the folders from our local system. Let us select a car image from the system and then click Upload Image. The image from the local system to the web page was uploaded, and now the license plate is retrieved from the image and it was displayed in a text box. Now, when Get Details was clicked, the license plate retrieved from the image is checked with the database details. If the match was found from database, the details are displayed. Here, the match was found from the database, so the details like license plate, owner name, car model, car color, model released, email of the address, and address of the owner. These were displayed on the web page. Let us check with one more example. Let us choose again one car image and click on the Upload Image button. Here is the result which was displayed, and when we click on the Get Details button, the details were displayed. Here the license plate was checked with the database details. Let us go with one more example. Choose a car from the folder and click on Upload Image. When you search a number plate and it goes to the database and validates according to it. And it's a rare case when a user is not found in the database. If that happens, the registration details won't be displayed. Here it is the rare case which was not stored in the database. So the result is registration details are not found. The steps what we are following. When an image is uploaded, KNN is used to extract the license plate from the vehicle. In this work, the proposed license plate recognition consists of three basic stages. They are pre-processing, plate localization, license plate number recognition. The license plate images are pre-processed through converting an image to grayscale. The grayscale considers each pixel of image which ranges between 0 to 255. and then blurs the image using Gaussian filter and find all the contour in image using OpenCV library. Contours can be explained simply as curve joining all the continuous points having same color or intensity. The contours are a helpful tool for shape analysis and object recognition and object detection. In license plate localization, KNN algorithm is used to find all possible characters in the image. The last step is done by cropping the part of an image with license plate and then apply the pre-processing and license plate localization again to find and recognize the license plate in the cropped image. After detecting the plate, above extraction steps to recognize the characters and numbers in license plate. We need to apply these steps. Each character and number in the license plate should be segmented using KNN to recognize each character and number using training data. Each character will be matched with the training data and of KNN to recognize the characters. Now, architectural flow. When user uploads an image on the web page, then the image goes through all the three steps we specified before, such as pre-processing, license plate localization, and character recognition. After extracting all characters from the plate, it checks the extracted license plate number with the BMV or DMV database. The database we are using here is SQLite database. If a match is found in the database, then the registered owner details are displayed on the web page. The details will be like owner name, car model, model year, and owner address, etc. Thank you.
Thank you for watching a video on Insight Hub. The video series brought to you by Miracles Data Practice. For more videos, please visit miraclesoft.com/insighthub.